This is a video on the interval of convergence. The question states, find the interval of convergence of the summation from n equals 1 to infinity of n factorial squared divided by 3 times 5 times 7 times times 2n minus 1 times x to the n. So let's start by using the ratio test. We take the limit as n approaches infinity of a sub n plus 1 over a sub n. So if I plug in n plus 1 where I see an n, I get an n plus 1 factorial squared upstairs. And then for the denominator, if I plug in n plus 1, 2 times n plus 1 minus 1 is 2n plus 1. So we're multiplying 3 times 5 times 7 all the way up to 2n plus 1. And I included the 2n minus 1, which is the previous factor. And then times x to the n plus 1. So now let's divide the fractions by multiplying by the reciprocal. And then I'm going to regroup. So I'm going to put the factorials together, the powers of x together, and these odd numbers together. So let's see what we can cancel. The 3, the 5, the 7, all the way to the 2n minus 1, all those cancel. And I'm just left with a 2n plus 1 in the denominator. N plus 1 factorial over n factorial, that's just n plus 1, because the n plus 1 factorial means n plus 1 times n minus 1 times all the way down to 2 times 1. And the n factorial has the n times n minus 1 times all the way down to 2 times 1. So everything cancels except the n plus 1. And x to the n plus 1 over x to the n is just x. So what I'm left with is the limit as n approaches infinity of n plus 1 quantity squared times x over 2n plus 1. If I plug in infinity, I get infinity over infinity, and I can invoke L'Hopital's rule and take the derivative of the tops and the bottom, and I get the limit as n goes to infinity. The derivative of n plus 1 squared is 2 times parenthesis n plus 1, and then I still have my x. The derivative of 2n plus 1 is just 2. Now if I plug in infinity, I get infinity over 2, and that's just infinity. And I'm using the ratio test, and the ratio test says that I'm supposed to compare this with 1. Well, infinity, of course, is always greater than 1. So the ratio test tells us that this diverges for all values of x, except there's a special case which I need to take note of. If x is equal to 0 here, then this whole fraction is 0, no matter what n is, and that's less than 1. So I can conclude that by the ratio test, the series converges only at x equals 0. We say the radius of convergence is 0, and the interval of convergence in this case is just from 0 to 0. And I'm done with the problem.